things. Let's have this logarithm here. Let's say we have a logarithm of base 2 of the argument x minus 1, and to it we have added again logarithm of base 2 of the argument x minus 3. And all of that is equal to 3. So the first step we can take with this equation is recognize the bases are same. The base is 2 and 2 in both logarithms. When we have two logarithms of the same base added together, we can rewrite them as one logarithm of that same base with the two arguments multiplied inside the argument of this new only one logarithm. So x minus 1, x minus 3 in multiplication. These are these two arguments because these were added. And we can write it as one logarithm. That's a property of logarithms. The right side stays the same. And whenever we have a logarithm, there's this identity that basically the base of the logarithm to the power of the right side equals the argument of the logarithm. So we can say that 2 to the third, so the base of the logarithm to the right side of the value when we put both a base and argument to logarithm, the numeric value on the right side is the exponent for the base, and that should equal the actual argument of the logarithm. So basically this equation asks us always 2 to what power will give the x minus 1 times x minus 3. That's the idea in this case with these concrete values. So this equation can be directly with information rewritten as 2, so the base to the right side equals the argument. Another sort of identity within logarithms. And this gives us a quadratic equation. This is 8, and on the other side we can multiply it out. Now we can have 0 equals x squared minus 4x minus 5. And we can factor it into parentheses to get directly the results for this equation. So we can say x minus 5 times x plus 1. Because the way if we multiply it out back, we will see it actually really equals this. So that's nice. Another thing to notice, how we factored it is we take these numbers on the right. When we add them, they should give the coefficient at x to the first term. So that's minus 4 here. When we multiply them, it should give the constant term, which both is satisfied. So this equation tells us either x is 5 or x is minus 1. The reason is that when either of these two is 0, then on the other side it's true that it's 0. Take 5, this is 0, then the whole multiplication is 0. Or if x is minus 1, then the whole multiplication is 0. So with that, we now have two solutions for x. But we should refer back to logarithm because we had inside the initial, we have logarithm base 2 of x minus 1 and logarithm base 2 of x minus 3. There's a property with logarithms that the argument should be strictly above 0. So it should be x minus 1 strictly above 0 and x minus 3 strictly above 0. This gives x is above 3. This gives x is above 1. So we can take numbers from the solutions we actually got after all the steps, those that fulfill this. And of the two, it's only the x plus 5. That's the solution because x minus 1 is below 0. And then both x minus 1 and x minus 3 would be below 0. But with logarithms, we must have the argument strictly bigger than 0.